Object-Oriented Programming, OOP, Part 1. What we're going to start doing is examining Java's power now. So far, we've been really just looking at the syntax, and the syntax is what helps the gears and the cogs kind of work and move. But as far as designing very, very powerful applications, the real power in Java comes from the fact that it's an object-oriented programming language. And that's exactly what OOP stands for. So what exactly does it mean to be object-oriented programming? What is that all about, OOP? So we'll talk a little bit about that. And then we're going to move immediately into the crux of the conversation, and that's dealing with objects and classes. And they're very similar, objects and classes that is, and yet they're extremely opposed to each other, or rather, they're extremely dissimilar. I'll be honest, the terms objects and classes are interchanged and used quite often in an interchangeable fashion. And even I might kind of get lazy and do that. But I want to clearly explain to you the delineation between the two. Then we're going to talk about designing classes, what that's all about. Now, once we've designed a class, we want to use it. So we'll have to create it. And then when we're done with it, it's got to go away. We have to reclaim the memory that class is taking up in memory. Now, here's the deal. Java has a real special way of doing object destruction or destroying the objects that we'll talk about too. So what exactly is OOP? What is that all about? What makes one language object-oriented and another language not? What are the differences between object-oriented programming and other languages? What are non-object-oriented programming languages called? Well, I just kind of posed to you a lot of questions that I've run across over the years and used to kind of stimulate you to think about, the different types of programming languages out there. Now, when I say the different types of programming languages, I'm not necessarily talking about the different names of them, like C, C++, Fortran, Pascal, COBOL, things like that. What I mean when I say different programming language is I mean the different type of philosophy around that programming language, or the characteristics and the nature of that language. What does that language allow you to do? What doesn't it allow you to do? Without getting into, like a 500 level college level class on, programming language theory, let's just put it to you this way. Some programming languages fall into a category called procedural. Procedural programming languages only allow you to go from step A to step B to step C to step D, and you can't get to C unless you've done A. You can't get to D unless you've done A, B, and C. You can't get to C unless you've done A, B, this kind of a thing. Well, procedural programming languages were great in the early years. For example, Fortran is a math-based language that is still used to this day for developing systems to help do weather patterns and determining weather calculations. It's good and is highly used in the meteorological circles. However, the world we live in, the business world, which is where we really live, I guess, isn't that straightforward. The world we live in is more object-oriented, meaning that we have interdependent sets of objects, each working harmoniously together. And we need to be able to have those objects work independent of each other and sometimes dependent of each other, and then sometimes interdependent of each other. And that's where object-oriented programming languages come in. Now, what defines an object-oriented programming language? Well, there are these 5 characteristics that a language must meet in order to be considered and classified as object-oriented. The first thing that you have to be allowed to do is work with user-defined data types. User-defined data types allow you, the programmer, to come up with your own data types. Earlier, we talked about the 8 primitive data types, the numerical data types, integers, characters, float, double, long, and bit. We also, and short, we also talked about the one non-numeric, which was the Boolean, which is true and false. Well, it's kind of hard to describe real-world business problems in terms of numbers and true and false. I might need to define it in terms of employees, or computers, or pens, or eraser tips. Then I need the ability to kind of go beyond numbers and true and false. And that's where user defined data types come into play. Now, a big feature of object-oriented programming is the ability to write code once and use it frequently, over and over again. Write once, use it a ton of times. And one way of doing that is by using inheritance. And Java not only allows you to define your own user types, but it also implements what's called implementation inheritance. And that's where I can have objects that relate to each other, building off of each other's functionality. Something else I can do is I can do data hiding in Java, which is another characteristic of object-oriented programming. Data hiding means that I can have an object that has its own little personal secret and only it knows about it. And I could do that for security purposes in my coding. Encapsulation, another feature, means that I can have an object that is, quote, encapsulated with functionality. And to be quite honest, the user of that object doesn't even really need to know how the object works. You just need to know how to work with it. Take for instance your car, your automobile. If you're like me, my guess is you have some kind of a clue as to how the thing works, but, if faced with the task of rebuilding the engine, you're probably not up to par. Maybe you are, in which case that's pretty cool. But I'm not. What a car is to me is it's this engine underneath the hood, and the functionality of that engine is encapsulated. I don't need to understand how the car works in order to use it. Now, the car manufacturer provides interfaces for me in order to use that engine, like the accelerator and the brake and the gear shifter. Okay, but I don't have to understand how that works. I could not replace a clutch to save my life. Now, polymorphism is another great feature of object-oriented programming languages. Polymorphism, just to kind of have like a word study with you here, comes from Greek, right? You probably see the word poly in there and the word morph. Poly meaning many and morph meaning changes. Polymorphism is pretty cool. That means I can define something once, and then depending on a certain situation, it will learn how to behave accordingly. When I always think about polymorphism, it always sounds kind of like artificial intelligence programming to me. And you know what? On a very small level, it probably would be considered that. Now that I've given you the characteristics of object-oriented programming, let's kind of turn our attention to the meat of it, and that's objects and classes. Now, objects represent real-world things inside of the computer. And what can those things be? Well, it could be, and you'll have to excuse my horrific drawings here, it could be a person. And that person might be an employee, it might be a customer, it might be a teacher, okay? An object can also represent maybe a car. That's a thing. Maybe, something that Ford Motor Company or GM is interested in writing applications that help you deal with cars, okay? Maybe it's an airplane. Who knows what it can be? An object, and kind of think back to your English 100 or 101 or high school English, is basically a thing. It's a person, place, or thing. So now, okay, now, things have properties. They have ways of describing them that help to start making them unique. We call those attributes. An employee might have an employee identification. It might have a name, an employee ID, a start date, an end date, a salary, reports to, could have a lot of things. Think about all the attributes on a car. Color, number of doors, I mean, it's infinite. Number of doors, color, uh, make, model, year. It's mind-boggling how many things can describe a car. Now, things don't only have properties. In other words, you don't only describe them. And by the way, you could think of attributes like adjectives, okay? But they also have behaviors and actions or verbs that they perform, and those would be methods. An employee works, takes breaks, goes on vacation, An employee might go to lunch. Wow, I want to work for that company. Only one work and all breaks and going to lunch and take vacations. But I think you get the point. Think about all the methods or behaviors in a car. Go forward, go backwards, go to park, open the door, close the door. I mean, there's just an intense amount of behaviors or methods that an automobile has. Now, objects and classes. What is the delineator between an object and a class? Objects are real. Okay, they actually live in the computer's memory. They live in a special area of the memory called the heap, H-E-A-P. They can actually be seen physically. If you could shrink yourself down small enough to become like Atom Man and go into the computer's memory, you could see an object. Or you could measure it with, a device that lets you see how much memory you're using, or you could go to the properties of your computer and you can see the memory just increasing the more objects you're using. But programmers don't deal with objects. Programmers deal with classes for the most part. What is the difference between a class and an object? A class is the abstraction of the object. Programmers, much like an architect, defines the class, or like an architect defines the building in the blueprint. But once you've got your blueprint, once you've got your model, you turn it over to somebody to actually build it. And in our case, that would be the Java virtual machine and the computer and the operating system. We would say, here's our class. This is how the object is to behave. Then we issue a command to the computer to go ahead and build it. But we don't really work with objects. Now here's the unfortunate or lazy part, I should say. Because the line of delineation between classes and objects is microscopically small, it's become blurred, and most people use the term classes and objects interchangeably. And you know what? I might fall victim to that as well during the course of the series. But I just want to be very clear as to what's available in terms of how do we understand an object, what are the attributes and methods all about, as well as classes. All right, so now that we've kind of gone over some fundamentals of object-oriented programming, characteristics of that, objects and classes, let's go ahead and build a couple of objects. Now, before we actually go ahead and build an object, we have to design it. Now, the good news is we've been designing classes all along, albeit they've been kind of mainly used for demonstration purposes, but we've still been doing it. The most fundamental, most basic program in Java is at least one class, and that's exactly what we've been doing here. We've been building one class applications. Now, to be honest with you, you will build applications that will comprise of hundreds of classes. As I said earlier, a class represents a real-world entity inside of the computer, like an employee, or a car, or a hard drive, or a pen. Now, something that I've kind of had fun with, this is kind of a side note, is I used to like to play the Age of Empires game, Microsoft Age of Empires. And that game had a ton of different warriors. They had like bombardiers and all sorts of guys. And one time I tried to write that Age of Empires game in Java. And I'd like to kind of show you where I've been going along with that. So let's have some fun here. And when I start building classes and do things with classes, let's kind of use the old Age of Empires model or something very similar to it. So like, let's create a class. In the real world, there would be warriors. So public class warrior. And one note on naming syntax, it is always likely that you would name your classes with a capital W, or a capital letter, I should say. Don't always name your classes with a capital letter, capital W, just a capital letter, because it's a proper noun, if you will. It's the noun, it's the main event here, it's the main thing. And then what I'm going to do is I'm going to start defining the class's attributes. Okay, like for example, the warrior might have a string and it would be, let's say, type or string type. Okay, so this would be the warrior's type. The warrior's, is it a crossbowman, a ninja, or a swordsman? Okay, that's the type. It would also have a string, let's say, not a sting, but a string called, we have the type, let's give our employee or our warrior a warrior name. So we'll have W name. And as a matter of fact, I'm going to change that to W type so I know that's warrior type. And these are just naming convention things. Okay. It will have a string of W weapon. The weapon it's using, is it going to be using, if it's a swordsman, is it a two-handed sword or a single-handed sword? If it's a ninja, does it have a samurai sword or a ninja sword, or is it throwing Chinese stars? I mean, what in the heck is this thing doing? If it's a crossbowman, what type of crossbow is it? How about an integer of number of weapons? So I'll say integer, and we'll call it int number of weapons. Okay, how many weapons is it carrying? Uh, Boolean. How about Boolean is active? Maybe he or she is not active right now. Or instead of active, that's not good. How about is good? You know how there's always a good and evil kind of a warrior. So those are the various ways that we can go ahead and define our warrior's attributes. Now, what's interesting about these attributes is these attributes are class level variables, or some people call them member variables. Okay, they're accessible to the entire class. Let's go ahead and save this. So I'll save this as, just to make sure, we'll save this as warrior.java. Warrior.java. All right, now that we got it saved, let's start talking a little bit more about access modifiers. Access modifiers are special keywords that I can attach to my properties or my attributes that kind of let me define some security. I can have an access modifier of private. Private, if I put private here, that means only this class has access to this variable. Now, it's accessible throughout the entire class. However, it is only accessible within the class. I just realized something. I need to make sure that this is a class. All right. So I have private. Something else I can do is I could put public here. Public means it's wide open. It's the opposite of private, if you will. Public means that it is accessible by any other class. Any class has access to public. Now there's two more we're going to talk about later on, and that would be protected. Protected. All right, hang on a sec. Protected. Here we go. That also has a certain level, but that also gets interesting when we work with inheritance, and we'll be working with inheritance in the sequel to this, OOP Part 2. So I'm not going to get too involved with that. And then I have the default level, and that means if I don't put anything attached to it. And there's something that we deal about with default level 2 when we come to the second part of this. So for right now, let's go ahead and leave them all public. So I'm going to put public, 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 and then public, which means it is wide open. Let's go ahead and save that. And just to make sure we're right on the right track, let's go ahead and compile this. Okay, you can see we've completed successfully. So that is using attributes. But as I said, something else we have available to us are are methods, and the methods give us the behaviors. When defining methods, the first thing that we're going to do is define the access modifier. So is this a public method or a private method or a protected method? So we'll just go ahead and say public for right now. Now, remember when I said void when we do public static void main? Well, what does void mean? Now we're going to talk about that. Void means that the method does not return any value. So you could call the behavior, but the behavior won't return any value. For example, when you call a calculator to add two numbers, you supply the calculator function add with a series of numbers, 1 plus 2 plus 3. When you hit equals, you expect those numbers to be added, 1 plus 2 plus 3 is 6, and then get the value of 6 returned to you. But not all methods return something. And if a method doesn't return anything, we say it is void. So I'll say that this method isn't going to return anything. So I'll say public void. Now, why am I not saying public static void? Static means that you do not need a unique instance of the class in order to use that method. Something that would be common to every instance, every unique instance of your class could in fact be static. So for example, I'll create a static method, public static void, and we'll say battle. I'm going to name the method battle, B-A-T-T-L-E, because all warriors battle. And in that method, I define what the method is to do. So really quick, let's review. First off, when defining a method, give it the access modifier, public, private, protected, or default. Right now we're going public. You can use the optional static. Static requires that you do not need a unique instance of the class or the object in order to call the method. All warriors have something in common here. This void here is the return type. If it doesn't return anything, you'll have void. If it returns something, you put the data type there. And I'll do a couple of those here shortly. And then the name of the method. Now, followed by an open and closing parenthesis. Now, sometimes we're going to have stuff in here, okay? But right now we're not. So this method is simply going to return system.out.println. It's going to return all warriors fight to the death. Okay, all warriors fight to the death. Now let's review this println method here really quick. Notice how I'm supplying the println with a string of data. That's because println takes as an argument a string of data. But our battle method does not. Also notice that methods are not capitalized, they're lowercase. All right, let's go ahead and compile this method just to make sure we're on the right track. All right, so let's go back. Now that we have a class, I've defined a class, let's go ahead and use it. Let's go ahead and use it here. I'm going to create a new class, and in that new class, I'm going to use the warrior. The first thing I'm going to do is create my new class, so I'll say new, and I'm going to call it public class use warrior. Okay, public class use warrior. And this is going to be like the starting point of the application. This is where I'm going to launch my application. So public static void main. Remember, the main method is the launching point for all classes in Java, in all applications, that is. So now you're seeing what public static void main string args mean. You see what that's all about. So let's go ahead and save this as usewarrior.java. So usewarrior.java. And here we can see that we have public, because it's public. Static doesn't mean we need a separate instance of the use warrior. Void, it doesn't return anything. So what can I do in here? Well, I can simply call my warrior class. I could say warrior, if I could spell, warrior dot battle. Can just call that. Now, because these files are in the same directory, they can see each other. They have access to each other, and therefore they can use each other. Things get a little interesting when we change directories, and that'll be when we talk more about packages. All right, so here you can see we've compiled it. So now I'm in the Use Warrior class. I am in the Use Warrior class. Now let's go to Tools, and let's run this thing. Let me show you what we get. So Tools, Run. And here you can see that's printed out to the screen. All warriors fight to the death. All warriors fight to the death. So let's take a look at what's going on here. This Use Warrior class is like representative of the .exe file. This is the launching point for my application, which happens to be called, by de facto standards, I guess, Use Warrior, because it contains the main method. Now, because the battle method is static, I do not need a separate instance of my warrior class in order to call it. So I can simply say warrior.battle. So anytime that you see a static method or a static property of another class, you do not need to instantiate it. Now what I want to do is put in some methods that require you to instantiate a unique instance of the class in order to have access to it. So here I am back in my warrior class. And what I'm going to do is I'm going to create a method. It'll be a public method. Public, I'm not going to say static, but what I'm going to do is I'm going to say string, and I'm going to say battle. Do battle. Okay? And what I'm going to do is I'm going to return. As a matter of fact, I'm going to rename this do, instead of do battle, I'm going to name it do battle, B-A-T-T-L-E, ninja. Ninja. Okay? Because this is what a ninja will do. And I will say throws fighting stars. I used to love those things as a kid. Okay, throws fighting stars. So that's one method. Another method would be public string do battle, and let's say crossbow man. And this method would return shoot arrows. Okay, what am I doing here? Well, first off, I'm defining two methods. One method is a public method, and it returns string, a data type of string, and it's called do battle ninja. That's why you see return here. That keyword means whenever this method is called, spit back whatever it's returning. Now, a method can only return one thing. Okay, so this can only return this string. And then finally, I can have do battle crossbowman, and then I can shoot arrows, and it will return that. So let's go ahead and jump back to the use warrior. And now what I'm going to do is I'm going to instantiate a ninja. So I'm going to say the data type, warrior, my ninja equals a new warrior. This is called object instantiation. And in order to instantiate an object, you first declare the data type of the object. It is called a warrior. Then it's almost like declaring a new variable, because maybe if I would do this, my ninja, that might make a little bit more sense, because remember int, my int, and then my int equals some value. Okay, so I could do it on 2 lines as well. But I've gone ahead and chose to put it back on 1 line. So let's kind of put it back on 1 line because you're going to see it most commonly in that way. So I'm going to say warrior my ninja, that's the data type, is a new warrior. Now, what is this? Where does this come from? Because if you look at it, I never put in a method called warrior that doesn't take any parameters. I didn't put that in there. Well, this is called a constructor. This is called a constructor. And a constructor is a special method. A constructor is a special method solely used for instantiating classes into objects. So now that I am calling the ability to instantiate an object here, okay, my ninja, watch what I'm going to do now. I'm going to say system.out.println, and I'm going to say my ninja, which is a reference to a warrior class or a warrior object, dot do battle ninja. And so what's going to happen here? Well, let's go back to the warrior class. We have do battle ninja. And when I call this method, I'm going to copy the name just so I spell it right. When I call this method, it's going to return throws fighting stars. So let's go back to here, the use warrior. When I call this method, do battle ninja, it's going to return throws fighting stars into the printline method, and it'll simply print out throw fighting stars. So let's go ahead and compile that and then run that. All right, so let's go back to the class and let's give this a shot. So I'm going to say run Java application. You could also do Control-1, Control-2 for, when you get a lot faster with the old shortcuts. All right, so what is going on here? Warrior.battle. This is where all warriors fight to the death comes from. Now, throws fighting stars. This is because I've called the myninja.doBattleNinja method. And it calls the doBattleNinja method, which returns the string throws fighting stars, puts it into the printline method, and that's why we're seeing it displayed to standard output. Okay, let's continue with another example. What I've done earlier is I created 2 classes. I created an employee class, and in that employee class, I created a couple of attributes. I created an int ID, string strf name, string last name, string title. One quick note on naming convention. What I do tend to like to do is I like to name the property or attribute with a prefix of a 3-letter abbreviation of the data type that I'm using, like int, ID, string, first name. And the reason why I like doing that is because I won't accidentally use a Java reserved or a keyword like, maybe title. Maybe if I just said string title, maybe title is a reserved word, it's a keyword. So if I just kind of append it with string, well, it's guaranteed to be mine, plus I already know it's a string. And then here I created a public method called string do work. So what I want to do here is I want to jump into the employee Java. So I guess before we do that, let me compile this just to make sure that we're on target with our employee class. Okay, and that compiled successfully. We can see the tool completed successfully. And then I'm going to jump into the use employee class, and I'm going to go ahead and do a employee, that's the data type, employee myEmp equals a new employee. And what I'm going to do here is I'm going to say myEmp dot int ID equals 14987. Okay, that's the employee ID. myEmp.strf name equals Robert. myEmp.strl name equals bar. myEmp.str title equals web developer 5. That's my title. Did I Get everything? I got ID, first name, last name, and title. All right. Now what I'm going to do is I'm going to come and create a print line method of that. And I'm going to do system.out.println. And I'm going to say welcome our new employee, welcome our new employee, and I'm going to do a close the quote, or space close quote, and I'll do my emp dot strfname plus quote space, put a space in there, my emp dot strlname, okay, and that'll say welcome Robert Barr. And then I'll say system.out.println, and I'll say employee ID myemp dot int ID system.out.println title, job title, and I'll do this should be a plus sign here, I just noticed this, plus my emp dot str title. All right, let's go ahead and compile this and see what we get. And we compile, so let's go back to our use Java, use employee.java, and run it. So I'll do a tool, and I'll go ahead and run the Java application. And here we can see, in a few seconds of anticipation, we get a bunch of stuff. It says, welcome our new employee, Robert Barr. Okay, so where's that coming from? On line number 5, I instantiated a unique instance of the employee class, and I called it myemp. Then I used the properties, and I went ahead and I said, I defined the attributes of my new employee. The int ID attribute, the string first name, the string last name, the string title. Here, on line number 11, I said system.out.println, in other words, print to standard output, which is the command prompt, the literal string, welcome our new employee, so that's why we see that, plus I appended or concatenated myemp.string first name plus myemp.string last name. Here I said print the employee integer ID or int ID, that's why we're saying employee ID 14987, and then finally I did the job title. One last thing I want to do is call the method. The method was do work. So let's call that and see what we get. So let me go back here. And let's do a system.out.println. And here I'll just say my emp.do work. And I'll compile that, and then we'll go ahead and run that too. All right. We compile successfully. Let's see the command results, and let's go ahead and run it. I did a Control-2 there, brings up my command window, and here in a few seconds we can see I get what I normally would expect, plus I get work, work, work. That's what I do, and that's coming from the do work method of myemp. Okay, so now that we've built a bunch of objects and learned how to instantiate them, how do we get rid of them? I mean, after all, the more and more objects we build and use, it's going to take up space and memory and really become a memory hog, right? Well, not necessarily. Java has a process of memory management called garbage collection. And this is how Java automatically adjusts and manages memory for you, which is a pretty neat little feature. Garbage collection basically finds objects in your computer, in the Java virtual machine, that are no longer being referenced, and it deletes them periodically. It's basically automatic deletion of objects from the memory heap. Now, we have absolutely no control over when that happens. There's a thread or a process that runs throughout the Java application that periodically checks the memory heap and says, hey, is there an object that's no longer available? yeah, or no longer being referenced. And it says, yep, and then it destroys it. So we don't know exactly when that happens. Now, we have some influence though, and that is we can set an object equal to null. So we could say myEmp equals null, let's say when we're done using it. And what's important to understand is when I set myEmp equal to null, that I am not explicitly causing garbage collection to happen. What I'm doing is I am saying to the virtual machine, I'm saying, hey, look, my emp is now equal to null. I no longer need it. Please delete it. So I would say equals to null. So you have to understand that this is a suggestion. It is not forcing garbage collection. There is really no way to force garbage collection inside of Java that is at least safe. And it's something I certainly don't want to really get into, but there is there is a method of the system class called GC, and you can call system.gc to go ahead and free up memory. But it is something that is very encouraged by Sun Microsystems not to do. In OOP Part 1, Object-Oriented Programming Part 1, I gave you a nice introduction as to what's going on with object-oriented programming, and I made you aware of the characteristics, the 5 characteristics: user-defined data types, implementation inheritance, data hiding, encapsulation, and polymorphism that a programming language must adhere to in order to be considered object-oriented. Then I went into some things to consider about designing classes, specifically putting in attributes and methods. Then I showed you how to use the new operator to instantiate an instance of the class. Then I talked to you a little bit about garbage collection. This is where we don't have to explicitly destroy our own objects like we would have to in C++. Garbage collection is a low-running thread, a low-priority running thread throughout the Java virtual machine that looks for unreferenced objects in memory and then destroys them for us. I hope you have found this informative, and I'd like to thank you for viewing.